So the first video was to guide you through the idea of planets and their atmospheres, what they're made up of, and how they're distanced from the sun. So here we have all of our planets. We've got Mercury, we've got Venus, we've got good old Earth, we've got Mars, a little bit smaller here, and then Jupiter, but Jupiter's one of the gas planets. We're going to set that aside for later. Right now we're focusing on the innermost planets, and what you're going to do, you're going to take Mercury aside for now. You're going to have Venus, you're going to put a planet X right here in the middle, you're going to have Earth, and then you're going to put a planet Y back here at the end. This video is going to guide you through the process of the project designing planets. Slide 2, you're writing an MLA heading. That's all. You are in middle school now. It's time that you need to work on writing your full name, telling what class period you are. All of these are great details that you need to put on each one of your assignments when you turn them in. Slide 4, these are the planets already in order from their distance from the sun. We're telling you this in advance. These are already in order. You're just adding details. Fill in the appropriate details. That's all. It should be pretty simple, but understanding which details to fill in is really the key. First part, distance from the sun. For planet X, you're going to put in anything between 108 and 149 times 10 to the 6 kilometers. Pick somewhere between those two values. For planet Y, anything between 227 and 149 times 10 to the 6 kilometers. That's the range there that you're looking for. You're trying to put them in between the planets that I've said that you need to put them in between. How do you think, now after you've done that, how do you think the distance from the sun would affect the temperature of those planets? The closer you are, the more solar radiation you receive, right? Okay, so if we're really close, we're getting a lot of solar radiation. It's really far away, it gets dimmer and dimmer. What we call this is the inverse square law. That means that the further away you are, if you're 10 times further away, then you have 10 times less solar radiation. And that would matter as far as how much heat you're absorbing from that solar radiation that comes from the sun. A planet can't heat up without some sort of energy. Usually the energy comes from the sun, although some parts come from radioactive materials breaking down, some leftover heat from impacts, but mostly it's coming from the sun. If a planet is closer to the sun, it has a greater source of energy to draw on to heat up. Next, surface density of the atmosphere. For planet X, you're going to write down anything between 65 and 1 kilogram per cubic meter. Choose somewhere in that range. For planet Y, you're going to do something between 0.02 and 1 kilogram per cubic meter. Those are your choices. Pick somewhere in there. How do you think the density of an atmosphere would affect the temperature of the planet? Once a planet absorbs solar radiation, the heat is held on by the atmosphere. Remember that Mercury has no real atmosphere. Mercury's our little tiny one, right? Mercury has no real atmosphere. When the solar wind blows past it, it heats up. It definitely heats up. During the daytime, Mercury gets really, really hot. On the sunlit side, it gets up to 800 degrees Fahrenheit. Hot. But on the nighttime side, it immediately cools down. As soon as it turns night on this side, it's going to cool down to negative 290 degrees Fahrenheit. That atmosphere is a layer of blankets that covers the planet, and the less dense of a blanket that you have covering in the atmosphere, the less heat it's going to hold in. So if you have a really dense atmosphere, you're going to hold in more heat. Composition of the atmosphere. Really here we're just looking for what's normal for planets in that region. You don't want to say, okay, I'm going to make an atmosphere that's made entirely out of methane, because that's something that's not that common there. You're not going to say something that is made totally out of water, because, well, there's nothing that's totally made out of water. So look at the planets that are on either side of planet X and planet Y. Notice how much greenhouse gas is in the atmosphere. If you have a high percentage of greenhouse gas, then your temperature is going to be higher. If you have a lower percentage of greenhouse gas, then your temperature is going to be lower. For planet X, you want to make sure that you have some major gases, some carbon dioxide, some oxygen, some nitrogen, but look at the differences between how much carbon dioxide Venus has, 95%, versus Earth that has much less carbon dioxide. Minor gases should include some combination of the gases on Venus and Earth, but they have to include argon and water. Those are something that are on all of these planets. For planet Y, major gases should be some combination of carbon dioxide, oxygen, and nitrogen, and the minor gases should be some combination of the gases that are on Mars and Earth, which would include at least some argon and water. Average surface temperature. For planet Y, now this is where we sum it all up. For planet X, anything between 15 and 464 degrees Celsius. For planet Y, anything between 15 and negative 63 degrees Celsius. All you have to do is pick a number in there. But depending on the other conditions that you chose, it could be on the higher end of the spectrum or on the lower end of the spectrum. So think about, if you had extra greenhouse gases, it's going to be warmer. If you had less greenhouse gases, it's going to be cooler. For slide 5 and 6, planet X and Y details. This is where you get to be extra creative. Tell me more, write at least use one sentence to describe anything about the planet's color, life, landforms, something like that. And then write one sentence describing its temperature. So you could say, it's cooler than this planet, or it's warmer than that planet, or it's somewhere in between. You don't have to actually start making an argument for it yet. We'll get to that. But for now, you want to talk about what it means, what temperature it has. Slide 7, planet temperature, rank, and evidence. We're building up a claim, evidence, reasoning. Rank the 5 planets in order from coolest to warmest. Number 1 is the coolest. And then why did you rank them this way? This is what I really want to see. I want to see claim, evidence, and reasoning. Your claim is which planet is the warmest and which planet is the coolest. Your evidence should be the distance, the density, and the composition of that planet. So that's where you're going to be providing data that would be evidence of why a planet is warm or cold. The reasoning is going to be on the next slide. Slide 8, planet temperature reason. Your reasoning should be why those details, density, distance, composition, matter in determining temperature. Tell me why they matter. Do reach out for help. If you have questions with this, give me a message on Google Classroom or email me or talk about it in class, but I really want you guys to be successful with this, and hopefully this is helpful.